Hi everyone, can you hear me? Please confirm. Can you hear me? Okay.
Yes.
So we'll begin with the first problem I sent in the chat. This Headquarter problem. I sent two problems in the chat. Okay. We'll begin with the first one. Take a look at it and read it for 2 minutes, and then we'll discuss it. Okay. Okay, I'll explain the problem now. So we are given k items placed on a grid of squares with r rows and k columns. And we want to begin at the at the leftmost upper square, which is 1 1, and then reach the right bottom square, which is RC. So our goal is to go from there to there with with the maximum score possible, and the score is the items that we pick on our way. Okay. So for example, let's take this first example here. So this is the number of rows 2, and number of columns 2, and k is 3. Okay. So the input is given in this way. We are given k items, and for each item we are given the number of row and column it begins. Okay, so the cell, so the number of row and column for the cell this item below. Okay, so here it's clear we have a matrix of size 2 by 2. Let's begin putting each element with 0 for first. Okay, and then at 1 1 we have an item with the values 3. Okay, and at 2 1, So at row number 2, at column number 1, we have an item with value 4. And at 1, 2, we have an item with value 5. Okay. So there is, yes, so there is a condition here we want to meet. At most, so we want to pick items such that we pick at most 3 items for each row. Okay, so I cannot, so if I have a matrix like this, so if I took 8, then for example 8, then 8, I cannot take 6 because I have used 3 items. Okay, so I cannot take more than 3 items for a row. Okay, and also I can, yes, also I can move right or down. So I can, this means that I can only take up to 3 consecutive items in the same row. Okay, so I can at maximum take this, then go down, or I can take these 3 items and then leave an item and then go to the next item and then go down and so on. Okay, so here we have many situations and we have multiple possibilities. So to think how to solve this, I think it's optimal to solve it using DP. Okay, so start at first cell, and then look if I'm gonna take it or not. So if I'm gonna take it, then I'll go to the next to the right or to the down cell, but I want to count the number of cells I've taken so far in the same row. So that means if I crossed three three items, so if I took more than 3 items, I won't take I won't take the same cell again, or I won't take any cell again. Okay. So let's make a function and I'll explain better here and explain everything in details here. So let's forget about the input now, but let's say we have the matrix here filled with items. Okay, we have a matrix here filled with items, and whenever there is no item, so it's of course not all the cells have an item. Okay, so whenever there is no item, I'll just make it 0. Okay, so item is a positive value, no item it's 0. Okay, so here I want to make a function that takes 3 values, I, j, and c and t. ij corresponds to the current cell I'm standing at, okay, and c and t corresponds to the number of items I've taken so far at the same row, okay, so at row number I. So that's it. So uh, if I'm cell number I and j and c,
Ahmad, sorry to interrupt. Can you please explain the question? It's not clear. Can you please once again explain the question itself?
okay,
Yeah, thank you.
okay. So first we are given a matrix of size n times m, which is r times c. Okay, so here I'm given r and c. So the matrix is of size is of r rows and c columns, and then I'm given number k. Number k corresponds to the number of items I want to put in that matrix. Okay, so this is the explanation of any matrix. Uh, so this is the size of the matrix, and this is the number of items I want to put in the matrix. So the items are given in this manner. Um, the coordinates of the cell, which is R and C for each cell, and then the value of the item. Okay, so here we are given 3 items. The first item is that at cell 1, 1. Second item is at cell 2, 1. Third item is at cell 1, 2. Okay, and I'm not given a cell at this cell. I'm not given an item at this cell, which is 2, 2. Okay, so what the problem wants us to do, is we want to start at the leftmost cell. So let's take a bigger matrix here. So this matrix corresponds to 4, 7. So this matrix has four rows and 7 columns. Okay. So the input for this matrix is 4, 7, and some k. I didn't count this. Okay. So k is this number of items. Okay, and this 0, 0, 0, these are empty cells that doesn't have item. So our goal is to start from the first cell, the uppermost left cell, and then go to the the downmost right cell. Okay, so we want to start here and then go here, and we can only move right or down. And at each cell we are at, we can take the item and put it to the value. Okay, and add it to the score. So initially we have a score equals to 0, and if we are at this cell, we can add it to the score. So we'll have a score 8, and then go to the right cell and then add another 8 to be 16, and so on. But and then we can go here to the 6 and then add 6, so it will be 22. Okay, and so on. But there is a condition that we cannot take 3 items from the same row. Okay, so if we have gone to this 8 and then this 8 and then took this 8, we cannot take 6. Okay, that's it. But we can continue. So we can leave an item. So we can take this 8 and then leave this 8 and then take this 8. Okay, so that's it. We can move whatever we want, right or down, and take an item or don't take it. And we want to maximize our score until we reach that last cell. Did you get it now?
Yeah, so that means it need not be continuous.
Sorry, what did you say again?
So that means that it need not be continuous elements that needs to be taken.
Oh, yes, it may not be contiguous. Yes, I misread that. Okay, sorry. Okay, so we can take this 8 and this 6 and this 4. Okay, uh, but then if we go down, we are narrowed. We are narrowed by this small matrix, so we cannot go left again. Okay, so let's explain how we can
So we
do.
we
Oh
have to
yes,
return the maximum score, right? That is the
yes.
output. Okay, I think I got it. Okay.
Okay. Okay, so now we want to make a DP approach, um, and it will be so. A simple problem is this. A simple problem of this is without having this condition of count number of 3 items. So this would be like basic idea. We stand at any cell and then take the value of it or not. That's it. Okay. So if I don't have the condition of 3 items, then I'm at cell ij. Then either take the value of it or not, and then go right, try get the maximum of right and down. That's it. But then we have now CNT, and it stores the number of items I've taken so far at the same row, means at row number I. Okay, so let's forget about the base case now, and then let's go to the transitions. How can we get the value of solve IJCNT? Okay, so here I want to check first if I want to take cell ij. So if I want to add cell ij to the score, then I want to check if CNT is smaller than 3, right? So if CNT is more than 3, then I could make, so here I make int r, so this is the the value of the current state. Okay, result. So I'll make result equals, if I want to take this cell, so I want to check 2 states. So either take it and go right or take it and go left and then take the maximum of them. Okay, so I just make mat of I of j. So this is the value of this cell plus solve. So I could go to the next row and with the same column, but then I'll reset CNT to 0, right? Because I changed the row So the second row, I I won't have taken any item from it. Okay, so here will be 0. Here I will make max. So I'll take the max between either going down and resetting CNT to 0, or going left and then increasing CNT by 1. Okay, so that's it. Uh, of course, we have another conditions, but here's the condition that we want to take the current item. So if we want to take the current item, then we'll take it and then get the max from solving right or solving down. Okay. Okay. So now, what about not taking it? So if I don't want to take it, then I'll put result. I'll put the value of result to solve I plus 1j 0. So now realize that I didn't put mat of I of j. Okay. So result will initially be the answer of either going down or going right, but without taking the current item. Okay. And the same thing, resetting CNT to 0. No, not CNT plus 1. Okay. So I realized I didn't take the item, so I've gone to the next column without adding 1 to CNT. Okay. So that's how we calculate the result. But there is another thing. So we calculated here the result without taking the current item, and then here we calculated another result but with taking the item. So I want to take the maximum out of these values. So I take maximum of result or this. So did you get this transition? So this is only our answer. Did you get this?
Ahmed, I didn't get why when we are going towards right, we are sending the count as 0, and when you are going down, we are sending the count as the actual count.
Okay, it's in reverse now. So it's the opposite way. If I'm going down here, I'm setting it at 0, not if I'm going right. So I plus 1 is down, and j plus 1 is right. Okay,
Okay.
okay. So that's it. But what about the base case? So the base case would only be if we crossed the matrix. So if we go to a cell out of bounds, then I'll just return 0. And if I have the matrix of size n times m, and it's a 0-based index, so if I'm at cell of row number n or column number m, then I'll just return 0 because this is clearly out of bounds. Okay. So if I equals to m or j equals to m, then I'll return 0. So that's our base case. Okay. Okay. Let's do a memorization now to make this actually dynamic programming. So the boundaries is 3, 3. So it will be of size m times 4. Okay, because we'll have CNT will store 4 values, either 0, 1, 2, or 3. Okay. So here we'll forget about this now. So if result equals to -1 means that I didn't visit this state before, then I'll calculate it from the beginning. Okay, so that's it. Now we've done our memorization, and then I'll return result. Okay, let's check if I'm missing any case. Okay, that's it. So now we're gonna take our inputs. So R will be N and C will be M. Okay, so take N, M, but then we'll have an integer K and take K. Now we want to fill the matrix, so I'll take K items, and for each item I'll take the coordinates of the cell that belongs to this item. So it would be X and Y, and the value of this item. But realize that we are doing zero-based index, and it's given to us with one-based index. Okay, so I'll subtract one from the coordinates. Okay, and then make mat of X, Y equals to value. Okay, and initially every cell is initialized to 0. So if I didn't put any item in any cell, so it will be just 0. Okay, so that's it. And then we print solve. So we'll start from the first cell, which is up at the left, 0, and with C and T equals to 0. And we want to fill the memo array with -1. Okay, that should be it. So did you all, before I tested, did you all understand what's going on in this DP? Any questions? Okay. Okay, everything should be okay, but there is one part that the value of the answer should be long, because it could overflow. Okay, so the values is up to 10 power 9, and we have up to 3 times 10 power 3 power 2 cells. So this will go beyond like 10 power 14 or something. Okay, so I want to make this long. And then okay, that should be it. Let's try submitting. Okay, this problem is done. I'll send the solution here in the chat. Okay, I sent it. Let's go to the next problem. So I sent the link of the next problem here in the chat. Take 3 minutes to read it, and then we'll discuss it. The code forces 1, okay?